A mid-air image is a real image formed through the reflection and refraction of light from a light source. The first research question is, where do users perceive the position of the mid-air image to be located? The second research question is, how deep do users perceive the depth of the mid-air image to be? In our study, the user is instructed to point to the nearest front and zenith of the sphere. First, point to the nearest front to determine its perceived position. Next, they pointed to the zenith. It clarifies the depth perception in a mid-air image by measuring the distance between 2 points. Pointing was performed on a real sphere and a mid-air image sphere. In the real condition, the sphere was attached to a rod and presented in front of the participants. When pointing, the sphere was removed, and finger position was measured with motion capture. In the mid-air image condition, the spherical mid-air image was formed using MMAP and 2D display. Participants first pointed to the position nearest the sphere, then to the zenith. In the real sphere condition, the same procedure was applied. This graph shows each participant's pointing position, with each point corresponding to one of the 4 in the right figure. The result shows that when pointing to the mid-air image, the finger tends to be positioned within 4 centimeters behind the image plane. This suggests the front of the sphere in the mid-air image was perceived on or behind the image plane. This graph shows the depth perceived by the participants. We found that more participants perceived a depth of below 5 centimeters in the mid-air image condition compared to the real condition. This suggests that the mid-air image is perceived as slightly shrunk compared to the real object.